Units and dimensions. Physics is the scientific study of natural forces and physical quantities. All quantities that can be described by laws of physics and that can be measured are known as physical quantities. Physics is known as one of the purest forms of science. Physics tries to use mathematics to understand and correlate various physical phenomena that we observe in our surrounding and the entire universe. The scope of study of physical phenomena, physical forces, and physical quantities is very vast, spanning from subatomic distances to astronomical distances, and so is the scope of various physical forces. We have extreme strong nuclear forces and our entire life depends on weaker gravitational force. A physical quantity is completely specific if it has a numerical value as a ratio such as refractive indices, dielectric constants, etc. Or it has magnitude only, such as scalar quantities like mass, length, speed, etc. A physical quantity can be completely specific as a vector quantity if it has magnitude and direction. For example, displacement, velocity, torque, etc. are all vector physical quantities that depend on direction and magnitude. Apart from these, there are some physical quantities that cannot be completely defined or specified even if both their magnitude and directions are known. These quantities sometimes appear or act like a scalar quantity and at other times it may appear as a vector quantity, dependent on both direction and magnitude. These physical quantities are known as tensors. Moment of inertia is one such example of tensors. Now we have discussed physical quantities. Our physical world can be considered as a huge structure which involves some fundamental or basic physical quantities that acts as pillar, and whole the other structure is made up of derived physical quantities that are based on those fundamental quantities. So, fundamental quantities are those which are independent of other physical quantities. There are 7 such known and established fundamental quantities, namely mass, length, time, temperature, luminous intensity, electric current, and amount of substance. One may get confused about mass and amount of substance. When we talk about mass, it is the matter contained in a particular macroscopic body. On the other hand, when we discuss amount of substance, we discuss about the matter or mass contained in atomic or subatomic bodies. The amount of substance is described in moles. Derived quantities. Derived quantities are those quantities that are dependent on or are derived from the fundamental quantities. So, the fundamental quantities acts as the pillar, and derived quantities are structures created over those pillars. Examples are speed, which is simply distance upon time traveled. Now, distance is a fundamental quantity representing length, and time is also a fundamental quantity. Similarly, density is equal to mass upon volume. Mass is a fundamental quantity, and volume is again a derived quantity that is dependent on the fundamental quantity of length. Now, when we measure a physical quantity in a repetitive way, then we need a standard system representing the definite amount of that physical quantity in a given circumstance. This specific amount is known as units of the unit of that physical quantity. A unit of a physical quantity is the specific reference standard used to measure it. Thus, a physical quantity is always measured in its standard value or unit. Without proper standard values, it would be difficult for a person to measure and compare any physical quantity in different cases. One may require to use different units in different scenarios. As for example, the length of a cloth can be expressed in meters or centimeters, but it would be better to express the distance between two cities in kilometers or miles. Similarly, the distance between the Earth and the Sun will be massive if expressed in centimeter or meter or kilometer. It would be better to express it in astronomical units. Now, a light year is also a distance, a unit of distance length that expresses the distance covered by light in an year. It includes many astronomical distances. Thus, a physical quantity can have a number of units, as there are many standard systems to express various fundamental quantities. Some of the commonly used unit systems are CGS, FPS, and SI unit system. In CGS system, we use centimeter for length, gram for masses, and seconds for time. In FES system or the British system, we use foot for length, pounds for mass, and seconds for time. In order to bring a sense of uniformity throughout the world, a standard international unit system was developed. As per SI system, the units of the fundamental quantities are as follows. Mass is represented by kilograms, kg. Length is represented by meter, m. Time is measured in seconds, as electric current is measured in ampere, A. Temperature is measured in Kelvin, K. Amount of substance, mole or mol. Luminous intensity is expressed in candela, CD. Now these are the 7 fundamental quantities and the units in which we express and measure them. In addition to these 7 fundamental units, we also have 2 more specific fundamental units. These are, first is radian. A radian is the SI unit of measuring 2-dimensional angles. A radian is the angle subtended by such an arc on the center of its circle whose length is equal to the radius of that circle. Steradian is the SI unit of measuring 3-dimensional angles. A steradian can be expressed as the angle subtended by such an arc of a sphere on the center of its sphere whose surface area is equal to the square of the radius of that sphere. Now we have discussed physical quantities, various physical quantities, fundamental physical quantities and derived physical quantities. We have studied the units in which fundamental physical quantities are measured. In the next section, we will discuss about the derived physical quantities, how they are expressed, what are dimensions, and how are dimensions used. Thank you.